All right, so this one's titled Successful Strategies for Deploying ONF Reference Design. So it's really, is this mic the problem? Can you turn that off? All right, so, Adtran, for those that don't know Adtran, we're a broadband access systems provider, but, about 4 years ago, we made the transition to this embracing open disaggregated approach, kind of using the data center architectural approach for delivering, building broadband access systems. It was really even before, I guess, ON Labs was still at that point just kind of being formed. We started down this path. So obviously Volta, ONOS, and some of those pieces, or ONOS was starting to come out, but some of the other pieces weren't there yet. And so we've had a good bit of experience, and once we've expanded out of kind of what's now called CEBA and Ethernet aggregation and other areas. So in this slide, I'm going to talk about really like what we see from the supplier community as far as the applications driving the adoption for ONF reference designs, and then for operators that are interested in deploying it, what's an actual practical approach to go forward and move forward and get these networks deployed. Because obviously, some operators have the wherewithal to go and do a lot of this themselves and build it and maintain it, but most operators are going to need some support, whether that's assuring the field deployment itself or even helping getting the system up and running and getting it operating in their environment. So we'll talk a little bit about that as we go through this presentation. Starting though, as far as what we see as the big changes in our industry that's kind of driving why we are even looking at these reference design architectures. And ultimately it's, there's going to be a lot of fiber densification around 5G. To the extent of that fiber densification, a lot of it depends on spectrum and other things. But either way you look at it, no matter what spectrum, we know that there's going to be a lot more fiber going to a lot more sites in the network. So that's going to drive up investment in fiber. At the same time, you have a lot of new applications, particularly IoT, that's driving this edge cloud infrastructure. And then you have, now that I'm deploying multiple networks, so I'm deploying a mobile network for 5G with fiber, and I've got enterprise customers that I need to connect via fiber, and I've got now more residential customers I need to connect via fiber. Maintaining 3 discrete networks is not really a practical approach. So overbuilding yourself with more fiber for different networks. And so that's where a lot of the technologies like PON, in terms of their scale, cost efficiency, come into play. And now how do I get multiple services on there? And what's the best way to automate and segment and do network slicing and stuff so that these services can all coexist? And that's what a lot of the things that you can solve with the ONF reference designs, or at least if you're looking for a blueprint about how to go address that problem, it's certainly a great starting point. And then ultimately, as far as this big trend, it ultimately comes to this last one that we're all here for. We do think that this common blueprint approach, that the large, especially the tier 1 operators, if they can all reuse the same baseline and contribute back and work with partners, supply chain partners that can help in a co-development arrangement, there is that crowdsourcing benefit that everybody can realize while also addressing the edge cloud initiatives, addressing convergence of services and just the fiber densification that's going to take place in future years. And so all those things said, when we go back, 4 or 5 years ago when we made this shift, we call software-defined access, but whatever you want to call it, open disaggregated networks, it's SDN-controlled, CEBA, whatever. They all kind of adopt these common principles. It's all about SDN control. That's pretty straightforward. Virtualize where it makes sense. Disaggregates probably, doesn't have the same buzzwords that SDN and NFV do, or as far as commonality, but that's a really big piece of it. Whether it's the hardware systems, the software systems, all of that. This is what fundamentally differentiates, a lot of the closed systems of the past is. And for a lot of operators, if you're building out a fiber access network, there's this thought that you can keep going with status quo and then later make this transition. That's really not accurate. When you talk about virtualizing a lot of the control plane software and everything, you have to kind of make those decisions up front in the architecture. There's not a simple, hey, I'll just take what I'm doing and just migrate it to Volta and fit it into a CEBA environment. You have to make that decision up front. And so anyway, so you have to pick a software architecture, hardware architecture, everything that's kind of builds on the disaggregated principles. And then obviously open networking, building on open reference designs. These are all key fundamental principles of what we call software-defined access, or what we'd maybe call in this room just CEBA systems. And as far as the end goal is, I think, what everybody's trying to drive to. It's, I need this network where customers can go to an app, it's machine-to-machine type communication, whatever it is, to activate services. It could be based on a preset criteria. It could be something they do through an app-based issued commands. But whether you're a residential user and you want to sign up for parental control services, firewall services, hybrid access services, whether you're a small business customer looking for better SLAs, service monitoring, SD-WAN, you name it, all of that needs to be done from a quick on-demand portal type environment. You would think that would be relatively straightforward. We're used to that app-based approach in all aspects of our lives today. But when it comes to broadband communications, it's not that straightforward. A lot of that, obviously, because the lack of programmability of the network. You have to implement a lot of these functions in software. You have to introduce service chaining, edge cloud infrastructure, all of those things to really get the full catalog. And so when you're thinking through, hey, I want that target architecture. I also want to converge services. I need the edge cloud infrastructure, all these things. That's where, obviously, the ONF reference designs can help us out. And so if I look forward, I'd date SDXS back to about the origins of that, back to about 2012. And that was kind of when the first white papers were coming out from the ETSI working groups about virtualization. And, a lot of the thought processes from the data center world were now starting to, move over into the telecom world. And so since this last 6 years or so, it's, obviously a lot of POCs, a lot of progress. We started, from an AdTran perspective, we did our first 10 gig PON ONOS-based trials starting back in 2015, so almost 3 years ago. A lot of that obviously was not field ready. Still working through that, but we'll see now with the reference designs, not just SEBA, but if you look at Trellis and others, 2018 is your first, tier one field deployments, and then really we see this fundamental shift. Obviously, you heard what DT is doing. Others, we see the transition now with multiple operators, tier one operators, really looking to push this into the field in 2019, and then you'll see probably 2020 being that scale up time frame for this starts to become the norm. I don't think there's a lot of debate anymore about if you had to pick a target architecture, the principles that would embrace and around open, disaggregated, et cetera. And I think there's probably no real debate if you were picking those principles and you had to pick a reference design or blueprint to follow, the ONF blueprints would be the most, those would be the ones that have the widest adoption in the industry. So we see that, really, here in this next 18, 24 months being really pivotal. That's why AdTran joined this year. We felt like we'd seen enough progress over the last few years. This is a real thing. It's going to happen. And so we need to become a partner, get more engaged, and help operators accelerate the adoption of these architectures. So anyway, that's what we did. Earlier this year, we joined as a full partner in ONF to help the ONF execute on that new strategic plan. We've seen this slide before, so I won't spend too much time on that. But how I was using this to kind of set up the next slide, which is really, you've probably seen something similar before, but I'll just show you my version of the, how all these reference designs fit together, just because I want to kind of reinforce, if we look back at the problem statement of converged services and other things that I'm trying to solve all of these, how would I, how do these blueprints mesh together? What are we seeing out there in the operators? So a lot of it is obviously starting with the NFV fabric. There's a lot of the building block. I see a lot of, Comcast talks about DAA aggregation and that's how they use NFV fabric. It's for DAA aggregation. We see this a lot with operators looking to go to 5G, looking to go to even G-fast DPUs, other remote nodes, needing a more high-scale aggregation platform, obviously even with aggregation of OLT systems. So what we see the value here obviously is, okay, now with white box hardware, open source software, I have a basic starting point for the leaf spine interconnectivity inside of my COs, exchanges, head-end hub site type locations to build from, and I can take that same control plane architecture, and if I want to enable broadband access, in addition to that, I'll take that same controller environment, add an access abstraction layer in Volta, add a few more apps into ONOS, whether that's a DPU in the future or OLTs today, And then along comes another set of network management functions pulled in the picture. Now, on this, I'll point out, obviously our goal is to help, operators realize the target state open source architecture. There are supply chain partners like Adtran that have a lot of these components today. So if you're looking for hey, I want to start now, but, and I want to transition to the open source components as they mature, there's ways to do that as well. So you don't necessarily have to do this, well, let me wait till, it matures over time and then I'll get started. I mean, a lot of these pieces that we show here, they're available right now and you can use them and then you can transition off. But I think the main point there is you want to get into this target state hardware architecture. You want to get into this, target state software that can gracefully migrate into where you're trying to get to over the next few years. And you're not going to get there if you just keep doing the same thing you did the last 10 to 15 years. There's too many fundamental architectural differences to really do that. And so anyway, this gives you your broadband access piece. We're using that same fabric switch architecture. Obviously, if you want to then transport that, there's a reference design for that. And if you then want to, and we'll see, obviously, there's a lot of talk within the ONF group about enabling edge cloud, moving into MCORD, and even moving into converged core architecture. And so this, so it's the collection, it's a holistic collection of all of this is where you start to see the value. So I mentioned, hey, I want to converge services. I need to support edge cloud infrastructure for IoT. I've got fiber densification. Fiber densification is driving the need for scalable PON architectures so that I can serve radios and residential users and business users all off on a common fiber network, some point to point, some PON. This is the blueprint I think you would want to start with because it covers all aspects of those big industry trends that we just named under a common blueprint, including how do I deploy virtual services in an edge cloud environment or our hybrid cloud environment and use things like a converged core architecture for both fixed and mobile. All of that is now encompassed in a common set of reference or a collection of reference designs. Not only that, you have this programmability and the continual innovation around programmability through projects like the Stratum UPAN project. And there's even the envisioned of, hey, how do I go from existing OSS systems into future orchestrators like ONF? So within this environment, like just from an Adtran perspective, this isn't necessarily a big sales pitch around Adtran. It's, what's our role in this as a supply chain partner? It's, well, we do have some of the components. We have DPUs, we have OLTs, we have some Ethernet aggregation switches that can kind of fit into this architecture. We have some virtual functions as well. We also help operators just, even if they're using white box or others, maybe provide software stacks for white boxes or just provide an integration function to piece all of these different reference designs together so that you can get moving. On the software side of things, on the control and management plane, there's a lot of those software assets that we already have. They kind of fit into this architecture. They complement the open source. They don't replace it. And then it allows you to kind of get started now and then kind of incrementally build towards your target state. And that includes the ability to hook all these systems up to your existing IT OSS. All right, so you don't have to, if your IT OSS system's used to talking to chassis-based OLTs, that's okay. We can still keep going forward with that without changing the APIs and then hook this into this architecture. So anyway, we see a tremendous amount of interest in this target. Obviously, not everybody wants every RD out of the gate. A lot of people want to pick like maybe SIBA or Trellis where maybe there's a little bit more maturity. Let's start there. But then the vision on how the longer term vision of how these different services converge together, I think that's extremely important. And a lot of operators see value in that. That role of the integration partner, I think, is critical. That's, again, we come from a systems vendor background. So, I know it may be a little different than a lot of systems vendors that, prefer to protect their incumbency. Obviously, there's some market share we would, stand to be cannibalized by these architectures. But when we look at it, it's, hey, we've got more to gain, less to lose, and we're willing to kind of embrace this open disaggregated approach. And if that means converting more into a software integration partner, fine. If that, taking on a different type of role than what we were accustomed to, Even without our hardware, that's fine. That's what the supply chain partners are intended to do. It's basically an operator wants to deploy it. They need the same SLAs they're accustomed to with closed systems. How do I get these deployed? How do I get them how did I get these reference designs engineered? You know, someone like Adtran or a collection of partners like Adtran would take on that role, take on that SLA. I know the DT guys mentioned that, you know, when they deploy, they've got a partner that will take on those SLAs. That kind of role is critical in ensuring the success of that. So that is there. So for the operators that are, hey, worried about, hey, I want to deploy it, but I'm not sure how to maintain it. I'm not sure how to, I don't have a teams of engineers that, you know, even someone the scale of a DT or AT&T might have, then, you know, certainly there's a role there that we can help out with. As far as the summarize the benefits of the, I think I've talked through a lot of it as we went through these slides, but just to kind of restate them a little bit, if you adopt these reference design architectures, there's going to be some, and the guy from Google and others did a good job of talking about this. It's really not necessarily the CapEx day one. That will come. This automation and convergence is really where you're going to get a lot of your benefit, like you're actually converging 3 or 4 networks into one common blueprint. You're reusing a lot of the same common software components, but everything's automated, so you're going to get a lot of OpEx through that. Then ultimately, you know, by the reduction of the duplicate network functions, there will be a lot of CapEx savings by moving to more open modular architecture where different white box vendors, hardware vendors have to compete with each other, and there's not as much lock-in because you've moved a lot of the intelligence from the control plane and management plane into the cloud. Then you're going to ultimately get some CapEx savings. The crowdsourcing is a big deal. Ultimately, like the idea that DT can do some work and contribute that, and AT&T can do some work, and Comcast and NTT and everybody can contribute back. That there's obviously, we've seen that everywhere in our industry. There are benefits to crowdsourcing, and you'll see that. One example of that is, you know, the Google guys that are doing Stratum. You know, all that work gets contributed back. So rather than waiting for a vendor roadmap on when are you going to get X, Y, and Z feature, you now have a community there that's continually innovating, and they're contributing that back. And as long as you're staying on the main line and staying aligned with the reference design architecture, then you can pull that in. And that's where a lot of supply chain partners also can help, right? We understand, you know, how to stay on track. You know, if you're part of the design teams, you know how to stay on track with the main releases and not fork off into your own little silo, which then defeats the whole purposes of doing the reference design in the first place. The solutions are much more easily adaptable, whether you're, hey, I want to go from a spine switch that's 32 by 100 to 64 by 100, or I want to go from a OpenFlow programmed one to maybe a P4 runtime programmed one that supports Stratum, or, you know, then you can do that much easier in this environment because all the real intelligent software is centralized in the cloud. It's not really embedded down in the boxes. And so as far as being much more interchangeable parts, whether it's the OLT or the fabric switches or any part of the solution, that's much more achievable in this centralized, you know, cloud-based control plane architecture. You also improve your time to market because inherently, if I need to launch a new service, let's say it's a new software service, I just want to do an over-the-top type service. If you have an edge cloud infrastructure, you have something I can load a ONF in, it's already automated, bam, you know, you can launch that new service very quickly. Even if it's something that requires new hardware, I want to go from GPON to XGS-PON, or I want to go from, you know, 10 gig aggregation to 25 gig aggregation, or 50 gig or 100 gig for, you know, radio technology, you know, future radios. Then adding a new fabric switch, pretty straightforward. Adding, you know, a new access line card into the hanging off a leaf switch, that's pretty straightforward. There's not this big, hey, I've got this big chassis system, and I've got to wait for a new switch module to come out that fits into the new backplane, and I got these thermal constraints I'm working in the chassis, and I got to wait for that vendor's new line card to come out. A lot of that goes out the window in these more modern disaggregated architectures. And so just the rapid change of pace you can introduce for both hardware and software components is key. And then finally, I kind of mentioned this multiple times already, but the convergence of reduction of the duplicated networks is big, right? And this is going to have to be something that I think all the big operators, especially if you have a mobile network, enterprise network, and residential, it just cannot make sense to continue to operate 3 networks anymore, which has been pretty commonplace over the past few years. And so if you're going to pull fiber out in the deep into the network for 5G and other use cases, then you're going to have to find out a way to reuse that network. And you're not going to then also want to duplicate electronics on top of it. So you need to find a way to not only have a common fiber network, but a common electronics aggregating those technologies. And so having a common blueprint that addresses all of that is big, and that's where we see ONF playing a big role. And I think that was, yep, that was my last slide. So any questions? I don't know how much. I think I probably got done pretty quickly, but yeah. So any questions? Sure.
How do you work with other vendors for testing the certification process?
Yeah, so how do we work with other vendors for the certification testing process? So I guess we have a wide range of partners. We have hardware partners. In that case, obviously, I mean, that would be the part of a supply chain partner. Like you can't expect to, I'll throw it out to the open source community and the lab here to take care of everything. So if you do want to certify these multi-vendor ecosystems or like, hey, I really like this vendor's hardware, this vendor's software, you're ultimately probably going to need, if you're an operator, you're probably going to need to go to somebody that's in an SI role to help you certify that. And so that's where, someone like Adtran would have an SI team and we'd set up a environment that's your exact specifications and, test and go through all the testing that you would normally do to release a closed product to the market, but do that in the environment. So that's the high-level answer. Now, obviously from an Adtran perspective, I mean, yes, we're used to working with other partners. We've done that in the past, but obviously it requires much tighter coordination when we're talking about low-level software integration and things like that. And I've got multiple people's software running on the same box, so it requires a much more sophisticated coordination. But anyway, bottom line is there's a path to do that, and ultimately that's one of the roles the supply chain partner can help with. Sure.
With the white box devices, do you see any danger that, especially with P4 coming up, there might be a danger that new programs and new services that come along might not be supported by white box switches you bought a couple of years ago, since they are much more, they require more resources? And this maps a bit to the question, to the presentation before that said that they have to last 10 years. Mm-hmm. But with the faster development cycles, you might end up not having these 10 years if services develop much faster than that.
Yeah, it's a good question. So, when you integrate functions like what DVT was talking about earlier, the service edge, you get into a lot more sophistication. If you're trying to pull those types of features into white box, that is one of the things that, certainly the benefits of programmable silicon. So like the P4 silicon is they do have more flexibility if you get into a jam and you need to add new features and capabilities. As long as it's much, I guess there's more scope for change. I would say the good thing is with these disaggregated architectures, yes, you'll probably find sometimes where you need to change hardware, but the process now in this open system, when you need to go to a new, maybe it is something like P4, for example, and that's one of the big benefits. Like and we make chassis systems, so I'm saying this from a vendor that has done this. Like if you ask me in our chassis OLT, like, hey, I really want a P4 programmable switch fabric because I need to do these different packet manipulation functions and I need to do it in hardware at terabit line speeds, it'd be like, okay, that's pretty complicated to change. You're dealing with the guts of the system. In these open architectures with the virtualized control plane, that's a pretty straightforward change. You've already got a vendor that can go in and build their adapters into ONOS, and they've already worked out the centralized control plane, and it's really going from white box A that was based on a fixed pipeline to white box B that has a P4 pipeline. That's actually not that big a deal. It's a big deal in a closed system, not as big a deal. So at least gives you a flexible framework in which you can make those types of changes that will inevitably come over time. I mean, you see the same thing in the OLT. Yes, we'll go from GPON to XGS-PON. you may require to upgrade the hardware or, just incrementally add. And the customers that want that service, you put on the new boxes, but that's pretty straightforward now. And it's not, you can't say the same in the closed systems. It's much more complicated. Or you're very beholden to whatever that vendor's roadmap is. And if it's not their priority at the time, then you're just going to have to wait for it.
I think one of the keys will be, and you were touching on it just there a little bit, is if I'm deploying GPON and I've got a fixed set of services that I want to deploy on GPON, we expect that GPON to last for 10 years in the network. I need to be able to deploy those services that I was designing and they're going to be there for a while. Now the platform is flexible, and if all of a sudden I see that I need a multi-gig service instead of a single gig service, and I go, GPON really doesn't get me a multi-gig service. Well, I add in XGS into the platform. I don't replace what's already there. I don't replace that thing that's living for 10 years. He's still providing the services to the existing set of customers that have bought what they want. For those new customers that you need, I add XGS in. I can now add XGS into my platform easily, or more easily, and then the multi-gig services have to go over XGS instead of over GPON. So I think the 10 years time frame is, I want hardware to live for a while. I'm not in a data center where I can replace my servers every 2 years or whatever.
Yep.
I want my hardware to live for a while. But I don't necessarily think that we're expecting hardware that we deploy today to magically be able to do new service offerings in for the next 10 years. I wouldn't see that. Maybe some folks do. Maybe
there's a little bit. I mean, if you have FPGA-based, piece, you can do some things within a reasonable scope. But changing line rates, that's a little more challenging, right? If it wasn't designed for that out of the gate. But I mean, there's some flexibility. But I would just say that the main thing is the system architecture allows much more flexibility. Even like what you'll see NTT as a demo with the pluggable OLTs. Like the idea that you could just go jump to that architecture, you can do that in this disaggregated architecture. You can't just make that leap easily if you're in a closed system like this. That vendor's probably not interested in doing it, and good luck, So, or in this one, you kind of have your choice, right? You're not locked into a single approach. So.
Another thing you could consider in this architecture is if I've got my infrastructure pieces, I've got my OLTs, maybe something that's easy to upgrade is some management plane devices, maybe the compute nodes. Maybe my compute is not really doing as much compute as I want. Maybe I can roll that compute upgrade without dropping a whole new chassis and saying I have to have a whole new chassis. Maybe it really is just about I need more compute. I can horizontally expand. I can in place upgrade the compute without changing out everything in the world. And so you get a much more flexible platform.
Yep. Agreed.
Thank you.
All right. Thank you, guys.